Today we will talk about Robinhood's enhanced workflow infrastructure supported by Airflow. Paula, Petru, and I will go through different aspects of Airflow usage in Robinhood. Let us do the introduce first. So yeah, I'm Kevin, work in the workflow infrastructure team in Robinhood for 2 years already. So we are maintaining the infrastructure of the whole company. Yeah, let me hand over.
Yeah, hey everyone, I'm Petru. I work for Robinhood for 1 year. I focus on the developing Robinhood workflow with Airflow. Yeah.
And I'm Pala. I also have been with Robinhood for a few years. I'm TL for the batch platform and the workflow platform within the data platform org.
Okay. Yeah, here is our agenda today. We will start with our use case at Robinhood. Then we will go through our Robinhood's Airflow infrastructure, and then discuss about how do we maintain the high availability and reliability requirements. And then after that, we will going through our multi-environment platform to support smooth development experience. Then we will talk about our recent migration to Airflow 2. And lastly, we will talk about our future plans around Airflow. Yeah, I will start with the Robinhood's Airflow use cases. The most important use case is trading related as stock brokerage. So we are using Airflow to charge margin interest to customers every day. And also every Friday after stock option is expired, we are going to exercise it. It's also triggered by Airflow. And also we use Airflow to pass cost basis from vendor and use that information to adjust our average cost for equities. Lastly, so we will actively check all equity orders for user restrictions before market is open. And the next major use case is clearing. So we are going to confirm executions within our brokerage and globally. After that, so we are doing the equity settlement on T+1 days to make sure all the orders are settled. Yeah. After that, so we also need to check all equities and cryptos we own are correct. Like some to make sure that corporate operations, for example, like two companies is merging, stock is split, and also the stock is delisted from the market. So we need to make sure that's working fine. And next use cases is the money movement. So we have thousands of transactions happens every day between bank and the Robinhood cash accounts. We need to do the batch transactions between that. And after that, we are doing the report generation as also triggered by Airflow. And also, meanwhile, we will feed our data for clearing and accounting usage for that. After that, we have a bunch of other backend services also use Airflow in different scenarios. We fetch news sources like we display the stock-related news for each stock, and this resource is from different vendor. And also we generate audience of notifications to send the notification to customers. Also we use it for data ingestion for our internal search engine, like which use the AWS Elasticsearch. So to maintain such many user cases, we need to have maintain good architecture of that. So let me hand over to Paula.
Thanks, Kevin. So as you can see, Airflow is pretty deeply embedded in our backend services for different workflows and different product flows. So let's look at what is the architecture that we have set up to enable this. So firstly, we have multiple Airflow cluster architecture. We don't have like a model of 1 or 2 Airflow clusters that handles most of the tags. We have separated out different clusters for different umbrella of business use cases. So we have separate clusters for trading use case, clearing, backend, in addition to the standard kind of like data and analytics use case. We have approximately about 15 Airflow clusters. And as you saw, many of the use cases are deeply involved with like, backend logic, right? Submitting reports and things like that. So this involves deep integration with backend services. So the model that we have is that different backend services that run their workflows on Airflow, they develop and deploy their own Airflow worker. And that worker is very tightly coupled with the backend service logic and code and everything. They're deployed together. So in a given cluster, there are multiple microservices associated with its own Airflow workers. And we have approximately about 80 such Airflow workers across all of our 15 clusters. So we looked at the high-level architecture of how we have set up Airflow. Now zooming in into a single cluster, we have kind of the standard expected components like web server and scheduler running. We also have the workers that I talked about running, and all of them are running on Kubernetes. Robinhood is a heavy user of Kubernetes infrastructure, and we leverage SQS as our queuing infrastructure for all the tasks to be published to the workers. We leverage Postgres for metadata. One thing that's interesting about our deployments, our clusters, that we have these multiple services that are integrated with a single Airflow cluster. Each of them have their own deployment requirements and constraints. For example, clearing, which happens at the end of after market close, we don't want deployment to happen at that time. But there are pipelines that are running daily, hourly, and so on. They may have different deployment requirements. So what we cannot start all the components, web server and scheduler with deploys all the time, because that conflicts with different backend services. So what we do is that we decouple the DAG deployment. So whenever the services are deployed, the corresponding version's DAG package is also published to S3 repository. Then we have a DAG syncer component running on our Airflow pods that always make sure that for every service that is responsible for, microservice responsible for, the DAG versions aligns with whatever is deployed in the backend for that service. For example, if you have a clearing service that has version A, the DAG package has to match the version A, and if it doesn't match, it tries to fetch it from S3. And so this is how we have set up the kind of our architecture there. So we have enabled multiple backend teams to integrate closely with Airflow. We have 80 workers running. Does it mean that all of these teams have to develop everything from scratch? No. So how do we do that? So all of the Robinhood services are deployed on Kubernetes clusters, and there already is an existing framework to allow easier backend service development on Kubernetes, which is called Archetype. There was even a blog post from Robinhood Engineering a couple years ago about that. So Archetype is kind of a short form definition of various components of a service. Think like databases, caches, other components. You may be running queue, you may be running other kind of logic, task pods, and things like that. We have added Airflow as another element in that template. So all a service owner has to do is instantiate the template, Airflow worker, and associate that Airflow worker with a cluster that they want to tie the service to. And then along with that, they define DAGs, where the queue is set to their own worker queue, and they have to publish the DAG repo. Then, once the DAGs are published, the DAGs are parsed by scheduler, sent to the queue, and will be processed by their worker. So in addition, for all the DAG code, the Airflow code that a worker needs, we provide a Bazel artifact. So that allows the teams to develop and deploy Airflow workers easily. Now coming to some of the properties that we want to maintain across our Airflow infrastructure. We want to maintain high availability because some of the workflows we're running are really, really critical. If we don't run them overnight, we cannot participate in the market tomorrow morning. So high availability is really critical. So the way we have set that up is we deploy all of our single Airflow cluster components across multiple Kubernetes clusters so we can survive a single cluster being down. We also try to leverage multi-AZ configuration whenever possible. In our pod deployments, we try to pin across multiple AZs. When our Airflow metadata, we leverage multi-AZ configuration. In general, we consider availability at every layer of the stack. The scheduler, worker, database, all of them are running across multiple AZs. And we also have we leverage SQS, which provides multi-AZ availability out of the box. And of course, Airflow 2 features for high availability that supports multiple scheduler pods running is also very critical. Coming to another property we want to maintain is reliability. DAGs have to start on time. They have to run on time. The mechanics we look at are various, but we try to essentially maintain reliability by monitoring a bunch of key metrics, DAG parsing time, deployment time, queue length, task instance failure, and so on. We also developed a custom metrics plugin where whenever Airflow metrics was not sufficient, we directly query a metadata database and publish those metrics and use them for monitoring and alerting. Another aspect is change management. Deploying changes to this cluster shouldn't break the workflows. So we have multiple environments set up where the changes go through, which we'll talk about in detail later. We have also set up backup and restore for Airflow metadata so that we can survive any sort of data loss that happened inadvertently. So we have this multi-cluster architecture, right? What are the benefits and trade-offs that we have? Isolation of workload is the primary benefit. We can really allocate dedicated clusters for really critical workloads and make sure that other noisy neighbors don't step in and affect these critical workloads. In some cases, the clusters are really small. They're not running thousands of DAGs, but this ensures that there's no scalability issue happening for these mission-critical workloads. Change management is another thing. Any kind of change that we want to roll out at the infrastructure level, we can roll it out for low priority to higher priority clusters. We can avoid critical time windows for different clusters and so on. While these are the benefits, there are also trade-offs. Upgrades are harder. We need to upgrade 15 Airflow clusters with 80 workers and require more work. We'll talk about how we have mitigated some of that with code gen and automated tooling. And ongoing minor upgrades is something that we are still figuring out and looking forward to look at the solutions from the community. Now I'll hand over to Kevin to talk about the multi-environment platform.
Yeah, thanks, Pala. So we are using multi-environment platform in Robinhood to improve the developer's experience. So the first environment is the Apollo. Apollo is our Robinhood in-house built and tested platform. So, and people can create their own namespace in Apollo and run the test from end to end. And it is also used for pre-commit and post-commit integration tests within our isolated environment. The architecture of Apollo is very like what we have in production. So we have Airflow server pod with different container to support web server, scheduler, and a DAG sync. And we use local stack to simulate the AWS resources, and this can make Apollo very close to the production environment to do the end-to-end test. The second environment is we own as the load and fault environment. So we use this to generate pre-prod environment for tests and integrate with other services in Robinhood. And we also use this to do the stress and the chaos test. So we have our own way to generate stress in Airflow. Like we have a centralized stack to create load test, and we use the configuration to generate dynamically. Okay. Yeah. As we see that we have our own load test stack, and we can use Airflow JSON configuration to generate different number of DAG fires, and the number of DAGs and the number of tasks. Also, we adjust sleep time to simulate the situation like DAG running very long time. After that, as you see in the below graph, the DAG fires will be generated, and after we turn on these DAGs, the test can be run. How we do it is that we use the create load test DAG. It will create all DAG files and upload to S3, and all the scheduler and workers will download that from S3 to kick off the test. After the test is done, we are analyzing the metrics from this different aspect, like the parsing time, CPU utilization, and DAG scheduling delay at these important metrics. So after that, we reach to the final stage of deployment. So we are the product is deployed for end users in the production environment. So yeah, next, so I will hand over to Pedro to talk about our recent finished migration to Airflow 2.
Yeah, thanks, Kevin and Apana. Yeah, I'm excited to share the story of our Airflow migration journey. We approach this with a side-by-side migration. So goals of transitioning our old and less scalable system to our modern cloud-native architectures. Yeah. So as we mentioned in the architectural part, our previous setup was based on the Airflow 1.10, deployed on the EC2 managed by Salt. Also use rapid message queue to distribute the Airflow tasks. And while this setup serves us well for many years, but it's become more clear that we need a modern and future-proof solutions. So we choose to upgrade our Airflow version to the latest Airflow 2 and deploy it using Bazel and Kubernetes. Also switch the message queue to the SQS. Yeah, so in this migration, we faced the challenge of migrate for 15 Airflow clusters, 75 application workers, and more than 4,000 stacks, and over 85,000 tasks. This process involves more than just straightforward transfer. We also need to upgrade our Airflow code to satisfy the new Airflow version, and while considering the massive interdependencies between tasks, even cross platforms. Moreover, additionally, like in each cluster, there contains critical and high impact tags that requires carefully handling. This tag cannot tolerate duplicate run and also has a strict SAA to meet. So it's important for us to guarantee this tag run consistently and reliable during migration. Moreover, we need to solve the potential compatibility issues within first-party or third-party dependencies. Yeah, so the migration itself was carefully planned and executed. We move one cluster at a time, and within each clusters, we migrate worker methodically. And task in the workers, we group as batches, start with low priority job first to smooth the transaction. Yeah, in order to solve the massive cross-platform tag migration, we developed a customized S3-based Airflow operator and sensors. They are utilize a S3 signal, which to indicate whether the task completion status. And we also extend our sensor to handle the daylight saving changes. Because in the Robinhood, we have a bunch of tags, critical tags or tasks, to tie it closely to the stock market close and open times. Last but not least, let me introduce this automation tool for the DAG migration, which ensure a smooth and effective DAG migration. Imagine that in each batch, we have 100 DAG over 1,000 tasks, and this can complete the migration with less effort. The system has a cluster of Kubernetes containers. Rendering container, once when a batch of DAG is submitted to the S3, pushed to S3, the rendering container will calculate the cutoff date automatically and push and store in our internal configuration system. The switch container will check this DAG in the old Airflow system, while Airflow API, once it completes the last DAG run before the cutoff date, the switcher will automatically pause it in the old system and activate it in the new Airflow system. Meanwhile, detect the container to check this migrate DAG status in the new system, sending alerts or page us if any failure happens. Yeah, so I'm also decided to share our bold future plan for our new Airflow. These aren't just the ideal, but actions we are actively implementing. We are in process of implementing the DAG authentication and authorization, which integrate our Robinhood Okta system, and based on the user subteam value. As you know, the Airflow internal user role has admin permission to all DAGs. So this is to enhance our security and improve our customer experience. We also plan to perform in-place Airflow version upgrades with zero or minimal downtime. This will be an evolution in our workflow system. Yeah. Plus AI integrates tools, auto-creating DAGs and workers with minimal customer input. Yeah. I'd like to highlight the key takeaways we are getting from our workflow introduction and development and migrations. So firstly, we will align our workflow platform to meet the fintech requirements, making integration with the multiple count of different applications or servers. simple and flexible. We set up the multiple environments to boost the platform stability and reliability, while also provide a personal development experience to improve the developer experience, gain the trust. And lastly, we also implemented an automation tool to migrate our DAX to a new platform. Yeah, this gets us towards success. Yeah, that's all our Robinhood enhanced workflow introduction. Yeah, thanks to everyone here.